Now the cable harness has two twisted pairs of wires, the red and black pair that powers the VTZ module, and the red, white, and black, white pair that's used as impedance sense leads. Optionally, some or all the harnesses also will have a battery unit temperature sensor which has a twisted pair of white wires, such as this one. That's the thermistor. Now, the cable harnesses are shipped unterminated. This provides flexibility of installation because you can shorten the leads as needed depending on how and where the VTZ modules get mounted. So once you determine the VTZ cable assembly length you need for your system, measure and cut the power and sense leads to that length. Now we strip 1/4 of an inch of insulation from each lead. Now we crimp the quick disconnect terminals on the power leads. Those are the black and red, and then the sense leads. Try to get a good solid connection there. There you go. Now we untwisted the cable harness leads so they can reach both battery terminals, but you don't want to twist too much. You want to keep the remaining cable harness twisted in order to minimize noise pickup. Now I'm going to connect this to the battery terminals, and the red and red-white go to the positive terminal. There we go. Red-white. And then black and black-white, they connect to the negative terminal. That's it. Now try to connect the power leads, solid red and black wires, to the closest tab washers to the battery terminal. Then sense leads attached to the tab washers above those. You want the solid colors to be as close as possible to the batteries. And make sure that the voltage polarity is not reversed. If you connect the cable harness backwards, it'll damage the VTZ3 module.
If it is required by the planned layout, you can mount DIN rail near the batteries to attach the VTZ3 modules to. Make sure to use the proper safety equipment to prevent accidental battery shorting. You can use metal snips or cutters to trim the length of the DIN rail and then secure it to the battery rack. Make sure to file the ends of the DIN rail to remove burrs or sharp edges.
Alright, now that we've connected the wiring harnesses to both these batteries, it's time to install the VTZ3 modules. So you want to match the VTZ3 to the appropriate battery unit using the unit assignment list provided with the CellQ1. The VTZ3 modules are configured for specific battery unit. Each module has an address that corresponds to the string and unit number that it monitors. If a module gets connected to the wrong battery, it will report voltage, impedance, and temperature incorrectly. So now we connect the module, and you would see that it's starting to flash green. That means it's getting power. That's good. And do it for this one as well. Same thing, flashing green. Now we got to mount the VTZ3 modules. And we want to mount them in a way that does not put tension on the connector or the cable harness. There are 3 options. You can mount it to the battery rack using the adhesive mount, which is what we're going to do today. We could mount to a DIN rail using an insulated screwdriver to pull this latch onto a DIN rail. Or you can mount the VTZ3 to the battery bus bar using a zip tie. So now let's just peel and stick. Very simple. and no tension, good to go.
So this is what you gotta do if you want to mount the VTZ to the DIN rail. First remove the backing and then mount right to the DIN rail.
For VTZ3 modules that have a unit temperature sensor in the cable harness, the sensors must be placed on the battery in a way that insulates it from moving air and provide a good measurement of battery temperature. Normally, the best place to mount the unit temperature sensor is between two battery units on the side of the cell near top of the plates. So if these two were closer, then kind of shoved between and right around here. And we provide a self-adhesive foam pad included for mounting the temperature sensors to the battery. What you do is peel the cover from the foam pad, revealing the sticky tape, and then fold it to a Z fold, kind of like this, and place the sensor onto the side, and the sticky side, and shove it between the two cells. Now this should provide enough compression between the batteries to keep the temperature sensor in place. So what we did in this instance, because there's so much space between the batteries, I flattened the foam pad out and placed the sensor right underneath. So it's insulated from moving air and it's pressed up against the battery pretty close to the terminals and getting a pretty good temperature reading.
For most CellQ1 systems used on GenSets, string current monitoring is not required. But if your system does, then the BVI3 and current transducer need to be installed. First, verify that the BVI3 serial number matches the CT serial number. These modules are calibrated together and are not compatible with mismatched CTs. Now separate the two halves of the CT at the jointer clamp. Clamp the CT around the battery cable and make sure the two red dots are pointed towards the positive terminal of the battery charger. If the nominal voltage of the battery string is more than 58 volts DC, the BVI3 must be powered from the CellQ1 auxiliary power output. If the string voltage is lower than 58 volts DC, then the BVI3 is powered from the battery string bus or the most positive plate and most negative plate of the battery string. For more information about the BVI, refer to the CellQ1 manual.
The CellQ1 communicates with the VTZ3 and BVI3 modules using a daisy chain communication cable called the S-Bus. The cables get attached from the CellQ1 controller to the first module, then first to the second, and so on, until all the modules are connected. The order of S-Bus connection does not matter as long as all the modules are connected. Make sure there's enough slack in each S-Bus connection so there's no tension on any of the connections.
Use the shortest S-Bus cables necessary between modules to minimize overall cable length. The maximum S-Bus run from the controller to the last module is 125 feet. You might have an S-Bus splitter module which allows the S-Bus to split up for up to 5 S-Bus runs. Here are two examples of an S-Bus splitter usage.
So before we mount the CellQ1 controller, we want to connect the ambient temperature sensor to this connection here. So it's a twisted white pair of cable, and the way to install it, you want to use your screwdriver and press in the orange part. Then you can put in the wire and pull out, and that's it. So to mount the controller today, I'm going to use these clip nuts, and the way it's going to work, these screws come out, and then the clip nut can hang over the ledge here, and then we'll connect them to these holes, and it'll be mounted right here. I'll show you how it looks. So we installed the clip nuts, and we're ready to clip it on, and done. There's lots of ways to install it, but whichever way you prefer, as long as it's sturdy and won't move anywhere, you're good. It's important to ground the CellQ1 controller properly to the closest ground. In the grounding kit, there's a green grounding cable which should be connected between the CellQ1 controller and earth ground. Strip the ends of the green cable and crimp the supplied ring terminals onto it. Connect the cable between the grounding lug and a good ground. You can ground the controller to the cabinet or rack if applicable. So all the modules are connected together through S-bus communication. The final connection we got to make is between one of the modules and the controller. Now it's ready to talk to them.
The CellQ1 has two sets of output alarm contacts that you can use to integrate with a building management system. The alarm contacts are 2-pin, normally closed relays. When an alarm occurs or if the controller is turned off, the alarm contacts will open. The maximum switching voltage that can be applied to the alarm output contacts is 175 volts DC. To learn how to configure which alarms will trigger the alarm outputs, watch the CellQ1 startup video.
So now we're ready to plug in the DC power. Make sure there's no fuses installed yet. So I'm going to connect right into here. Double check that in the power input connection, the red is on the right when you look at it horizontally and the black is on the left, just like indicated on the back there. And we'll put in the fuses. So we got these two fuses with the DC powering kit. I'm going to install them now, making sure that black goes to black and red goes to red. You got to insert the fuse and then you twist it in and then it locks into place. Now we're connected. And now we just power it on using the power switch. And we're ready to go.